Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is Apollo 11. With me here in the studio to talk about this fascinating experience are John McGill and Kevin Madden. Now, this month we're going to celebrate the 50th anniversary of Apollo 11, which was, of course, the first manned landing on the moon. We'll also celebrate the three brave men who made that landing: Neil Armstrong, Buzz Aldrin, and Michael Collins. So, John, to get to the moon, you have to have some control, places that take responsibility for getting them up into space and getting them into the moon. So can you tell us about these mission control centers?
Yeah, first I'll talk about the Mission Control Center in Houston. And basically that's where most of the monitoring and all the command is taking place. And one of the things about the Mission Control Room in Houston is that it has the trajectory boards, as you can see in the picture. And this is actually, they renovated the Mission Control Room, and this is what you can see right now if you go out to Johnson Space Center in Houston. So it's completely renovated. This was a 2-year project, and now it is complete.
Great.
And after, or before you get to Houston, you got to start off with the Florida at the Cape, and this is the launch control room. And at the launch control room, they don't have the big screen with the trajectory and that, but what they do have is the big windows where they can actually look out and see the rocket, and it's roughly about 4 to 5 miles away from the launch pad.
Okay. So we have the two mission control centers at Cape Canaveral and Cape Kennedy, and then at Houston.
Yeah, so once the rocket leaves the launch pad and it's up in the air, then everything gets switched over to the Johnson Space Center in Houston.
Okay. In Houston. Okay, so as soon as it's off the ground. All right. Now, there's communication that goes on between Houston and the spacecraft. And we've heard the term Capcom used. If you could fill our viewers in about just what that term means and what they do. Yeah,
well, here first, we're going to start off with some of the other people. We have the flight director. And the flight director, this is his console, and he's like the band leader, or, he has about 17 different flight officers talking to him at one time. And so he's just looking for keywords where, he can kind of filter it out, and then he'll talk. But anyways, then after the flight director, then we have what's called the Capcom. The Capcom, that's going to be, basically it's astronauts, and they're the ones that only talk to the capsule. And that's how it's capsule communication for Capcom. And
okay.
With that, during the Apollo 11 mission, they had over 8 different Capcoms. Everybody wanted to get into the party. So they all had their one little chance. But in this picture, you can see Jim Lovell back there, and the closest one to us is Charlie Duke, then Jim Lovell and Fred Hayes. But like I said, it got to be over 8 different ones.
But they were all astronauts.
They were all astronauts.
That was the critical part. The astronauts in the space capsule wanted to talk to one of their own on the ground.
Right, because they felt that they would know more what they were feeling and how to communicate the best with them.
Now, I understand there were various shifts that were involved with handling all of this?
Yeah, that would be the flight directors. And probably, probably the most famous one would have been Gene Kranz. And Gene Kranz was head of the white team. And the white team was in charge of the actual landing on the lunar surface. And his wife used to always make a vest for him for all his missions. And so he would open a package like a present right before the mission started and put on his white vest. And then there was also other flight directors for the lunar ascent and also the launch in the EVA, or extra vehicle activity, which was when they were walking on the moon.
Okay, those were designated by other colors such as black, gold, and green.
Exactly.
Yeah. So it sounds like it was a pretty well orchestrated operation. Now, Kevin, there were several different individuals that played important roles in this as well. Can you fill us in about?
Well, yeah, it's
some of
really
those?
easy to remember all the important names, like who the astronauts were.
Well, sure.
Various things like that. But there are also the young unsung heroes of not just Apollo 11, obviously, but the whole space program in general. And we're kind of going to go out of sequence here a little bit, but Steve Bales is one of the first guys that comes to mind because he was just a farm boy in Iowa, and he really didn't know what he wanted to do with his life. And he was going to Iowa State, and he was studying really hard. Finally, he saw an ad that NASA is hiring. He says, well, I'm not sure that's my strength, but we'll see what happens. So he gets in because obviously you need a lot of people for an operation like this.
Sure.
He got in, and they said, you're a computer expert. So he had to delve in to know everything possible about that computer, inside and out, upside down, whatever. So naturally, the one thing he fears is the thing that happens, and that's the famous computer alarms where, everybody's like, there's an alarm, and, he casually runs through his checklist and calmly tells, all the flight directors, we're go. So he understood enough about those alarms to understand the computer wasn't handling the amount of information that it was given. Because, obviously the computer that runs our iPhone is far superior to anything they had, 50 years ago.
Absolutely.
So, once he understood that you were just overloading the computer and the computer had to dump off the information somewhere, and you understood that you weren't losing anything vital, then they were fine.
Okay, and so that was the problem, that there was really no problem with.
Correct.
Now, a couple of other individuals.
Yeah, John Hubble, mild-mannered guy who heard a discussion about direct descent and Earth rendezvous. And he says, nah, maybe not. He says direct descent, that's Jules Verne's.
Sure.
Where you allegedly were going to get this big rocket to go all the way to the moon, put the reverse thrusters on, have it go backwards and land on the moon, and simply lift off, and everybody comes home happy.
Like we're kind of doing today, actually.
Right. So,
Yeah.
That was highly popular, but they weren't sure it was going to work. Then, of course, there was Earth rendezvous. A little more complicated than direct descent, but nonetheless, it was quite favored with people. And John says, no, you got to do lunar rendezvous. And of course, John's an idiot. Now, all his fellow engineers said he was, an idiot. Well, guess what? When push came to shove, the idiot won because the figure eight, as complicated as that illustration makes it, and yes, it is complicated because we had to extract the LEM from the command module and we had to do a lot of docking. It was a lot more complicated than direct descent, but it was the most efficient way of doing it, and that's the reason why we had all the lead up to Apollo, namely Gemini. Gemini proved that everything we needed to do in Apollo, was going to be workable. But probably the most important person is Wernher von Braun.
Yes, indeed.
Or as some of his co-workers would like to call him, that Nazi. So even
Well, that's in his background. Yes, it is.
20 plus years later, people can't forget where he came from. Even though he keeps insisting, look, the only way I could play with my toys is if I played along with what Hitler wanted. But somehow we got enough information that he was the one to nab when you were nabbing the Nazis before the Russians got him.
Right.
And to be fair, yes, he was making weapons, and they were weapons of destruction. But let's be honest. Why was anybody involved in rocketry at the time for the most part? It wasn't to be the next Jules Verne and dream of going to the moon. It was, how can I design a weapon to wipe out my enemy? But obviously, in the course of discerning between the V1 and the V2, how all that operated, we ended up with the Saturn V, which is, you know, the golden shining moment of Wernher von Braun's career.
And it got us to the moon.
Exactly.
And back. Several times.
So I mean, all politics aside, I mean, he may not have the most sanitized, you know, past in the world, but at sometimes difficult times do, require difficult decisions.
True enough. And like I say, if we hadn't gotten them, the Russians would have. So.
Exactly. And it wasn't exactly like we had a lot of in-house engineers that knew how to do rocketry.
Exactly. Well, this looks like a great time to take a quick break. We'll be back in just a few minutes with the second part. If you have a question, please send us an email. As always, we like to receive those. And coming up next is Term of the Month with Stephen.
Thanks, Don. The term of the month is LRO. The Lunar Reconnaissance Orbiter is a NASA spacecraft currently orbiting the Moon in an eccentric polar mapping orbit. The probe has made a 3D map of the Moon's surface at 100-meter resolution and 98.2% coverage, which excludes polar areas in deep shadow. Also, half-meter resolution images of Apollo landing sites were taken. The first images from LRO were published on July 2, 2009, showing a region in the lunar highlands south of Mare Nubium, the Sea of Clouds. That's when we were showing our second episode of Astronomy for Everyone, the term of the month, LRO. Back to you, Don.
Thanks, Stephen, and welcome back. The topic is Apollo 11, and with me here in the studio are John McGill and Kevin Medden. So, John, let's talk a little bit about the men of Apollo 11 and the mission.
Sure. Well, first off, we'll have to talk about the main man on the mission, and that would be Neil Armstrong. And Neil Armstrong, he was picked for leading this mission, and it was kind of out of the box pick because he actually had the least amount of hours out of any pilot. You know, they were mostly all test pilots that came into the program, and he had only 900 total time hours in flight time. Mm-hmm. But what they was in a rocket, because he was an X-15 pilot first. So he was the only one of the astronauts that actually flew a rocket. And also, he had spent the most time in simulator training, and so that's the only way that they trained for landing the LEM on the moon was with the simulator, because they couldn't figure out how to do, the gravity, the low gravity that they would encounter.
Right.
And so, anyways, so he was chosen as, the lead, the commander of the mission. And then the second person we'll talk about is going to be Edwin Aldrin, or Buzz Aldrin. And Buzz, he was kind of a little out of the box also, being chosen to be in the astronaut program. He was, I believe, the first pilot that was chosen that wasn't a test pilot. He had combat experience, but anyways, he wasn't a test pilot. But he also had a degree in aerospace engineering from MIT, actually a doctorate degree. He was PhD.
Oh, no kidding.
And also, Neil Armstrong, he was the first man to walk on the moon, but Buzz Aldrin, he also had a first and it's probably little known, but he was the first man to relieve himself on the moon.
Well, you got to figure they're hooked up for everything, and when you gotta go, you.
Yeah, and everything is documented. So,
Oh, no doubt, no doubt.
so in another little trivia was his mother's maiden name was Marion Moon.
Oh my.
Yeah. So.
Yes.
So then, anyways, then the last person, it's actually Michael Collins. And now, I chose this picture because Michael Collins is the only person that's framed in this picture that ever lived on the earth that's not in the picture. Everybody else that's ever lived on the earth is in that picture. So think about that.
It's quite a picture.
So yeah, so now we'll go on to the Apollo 11 patch. Now, Michael Collins, he designed this patch, and he had input from the rest of the crew and that. And basically, what's missing off of that patch is their names.
Right.
And,
All the other patches had the astronauts' names on
I think Apollo 13 also did not have them, but it's one of the few that does not have their names on it. In the first iteration of this patch, it had the olive branch in the eagle's mouth, and it had the talons opened up like it was coming in for landing or to grab something.
Oh, exactly.
And some of the higher ups thought it was too menacing a picture, and so then they came up with the olive branch and
Looks like he's
talons.
Bringing peace.
Yes, exactly.
In that pose right
and
there.
that goes back to the speech that Armstrong gave, and
Exactly.
the plaque that they left,
Exactly.
saying that we
Exactly.
came in peace.
All right. So that's an interesting story behind the Apollo 11 patch.
And yeah, here's one of the famous pictures. And Kevin, if you want to talk a little bit about that Saturn V again.
And that would be a shot of the first separation of the third stage as the second stage takes over to propel the rocket on its way to the moon.
And that's also the famous flagpole that sits right at by the time clock, and that's where all the dignitaries sat to watch the launch. And that's right in front of the media center,
Oh, right there at Cape Canaveral, yeah.
or Cape Kennedy.
Or Kennedy at the time. So this is an interesting image.
Yeah, that's the figure 8 again, and that was basically, they figured that was the safest trajectory to take, because if they would have came, on the right side of the moon, if they would have just did, like a NASCAR circle, that would have, the way the moon actually rotates.
It does rotate on its axis, yeah.
Well, it rotates around the Earth, so it does rotate.
Yeah. Mhm.
So if they would have went in on the right side of the moon, it would have boosted their speed, and it could have continued it like how we gravity assist off of other planets.
Exactly.
So it could have sent them off, and this was the safest way to get them back.
You bring them on the other side,
It
then the
slows
moon
it
can
down.
steal momentum from the space capsule.
Exactly.
Mm-hmm.
And there we have a picture of what was formerly called the Lunar Excursion Module, and now we just refer to it as the LEM, built by Grumman. And if anyone's a military historian, they would realize that Grumman built all the famous fighters from World War II that the Navy used. And the fact that they were asked to build the LEM was kind of interesting, because Grumman was used to building things that would last and could withstand being landed on a carrier, versus doing the LEM, which had to be as light as possible, and it basically has paper-thin walls. And on the angle of this shot, you can see the pads, and
There's something hanging from the bottom of the pads.
Right, which is kind of to give Neil the idea that he was close to touchdown, so he doesn't.
There were sensors before the
Correct,
actual.
because he needed to know, not even though Buzz was reading out the time and distance and how much fuel they had left, he still needed to verify how close he was to actually landing on the surface, which of course at that time we were only guessing whether or not, how solid it was and how deep would those foot pads go into the lunar surface.
Yeah, would they sink down or would they, have some support? That's true. That's true.
Yeah, and then this picture, this is showing where they were planned on landing, and then after, the 1201 and 1202, and they ended up being long, and so they were actually almost 4 miles down and 1 mile to the left. And
Okay.
that picture, if we go back to the other one,
Yeah, with the little red circle.
yeah, that's actually taken from the Lunar Reconnaissance Orbiter, and that actually shows the LEM, what's left, that's still
The
there.
base that
the
they took
base.
off from to come back to the capsule to head home.
And you can see how bumpy it was
Yeah,
where they landed.
Yeah.
And here we got Buzz Aldrin taking out a couple experiments out there. And here's one of the most famous pictures.
Yes, it is.
In the reflection, that's the only time you will see Neil Armstrong in a picture in that reflection. But this is a picture of Buzz Aldrin.
Okay. And Neil was the photographer.
Neil was a photographer. And this is the furthest away that they traveled from Tranquility Base. And that was the Little West Crater. And the whole amount would be like into the outfield of a baseball stadium or a baseball diamond. And the rest of it took place, all the rest of the excursion took place inside of the infield.
Okay. So,
Okay.
in the last couple minutes we have here,
This is Luna 15. And Luna 15 was the Russian orbiter, kind of like our LEM, and they tried to get to the moon and steal some samples from the moon and come back before we landed on the moon. And this was actually, they were there during the time our rocket and our men were on the moon, but they ended up crashing.
oh wow.
And there's a splashdown, and that was on the 24th of July.
1969. Can't forget. Kevin, you got a couple of books that you wanted to
Yep, sure.
tell our viewers about?
If you're looking for a book that's just basically a straight history, this is called Shoot for the Moon by James Donovan. He is a historian who writes mostly military history, so the fact that he took on something to do with the space program is quite interesting. Secondly, we have Douglas Brinkley's book called American Moonshot. This book is for those of you who want to know why in the heck did Kennedy want to go to the moon, and it explains the political circumstances as to what made him make that decision.
Sure.
And lastly, we have The Moon Mission in 3D by David Eicher, who, as everybody should know by now, or if you don't know, is the editor of Astronomy Magazine. And as you can see, the co-author of this book is Brian May. And you rock people will know that Brian May is the lead guitarist for Queen, but he also happens to have a PhD in astrophysics.
So
And
there
the
you go.
curious thing about this book is most of the images can be viewed in the viewfinder in 3D.
Interesting. Interesting. Well, I want to thank my two guests for filling us in on some information that maybe we didn't know about Apollo 11. Again, thank you both, John and Kevin. Don't forget to visit our club website. That email is down at the bottom of your screen as always. And coming up next to round out the show is What's Up with Stephen.
Thanks, Don. What's up in the night sky for July 2019? First of the month, the sun rises at 6 and sets at 9:13. This is Michigan time. On the 31st, the sun rises at 6:24 and sets at 8:53 p.m. So it's almost the same. It hasn't moved very much, and that's because the summer solstice was on June 21st, and we're still very close to it. The month starts off with a new moon on the 2nd, but also ends with a new moon on July 31st. The first quarter moon is on the 9th. The full moon is on the 16th. That's when NASA couldn't go back to the moon because it was full. And third quarter on the 24th. Mercury goes from Cancer to Gemini over this month. It sets at 10:23 p.m. and rises at 5:31 by the end of the month. It's better at the beginning of the month. The reason why we have setting and rising is because we had inferior conjunction on the 21st. That's when Mercury goes between us and the Sun. Mars goes from Cancer, so it's very near Mercury, to Leo over the month and sets at 10:26 p.m. to 9:23 p.m. over the month. Venus goes from Taurus to Cancer and rises at 5:11 to 6:05. It's better at the beginning of the month. Uranus is in Aries and rises at 2:23 a.m. to 26 minutes after midnight over the month. Neptune is in Aquarius, where it always is, rises at 36 minutes after midnight to 10:34 p.m. by the end of the month. And then Jupiter is in Ophiuchus and sets at 4:32 a.m. to 2:25 a.m. over the course of the month. Saturn is in Sagittarius, rises 9:35 and sets at 4:37. It's best all month because opposition for Saturn is on the 9th. Pluto is also in Sagittarius, rises at 9:55 to 7:55 over the month, and it has an opposition of the 14th. July is my favorite month for Pluto, because, especially toward the end of the month, because the end of the month, the days are a little bit shorter in the Northern Hemisphere. There is a dot in that picture just to the right of Sagittarius, which is the center of the Milky Way. So you take that rightmost star and you just go up a little bit. And that is what's up in the night sky for July 2019.